Okay, in this lecture I will solve few problems from the exercise related to lecture slides, absolute values and intervals. So there we are given question number 19. Question number 19 is absolute of x strictly less than 2. There we will use these properties of the absolute. Here, as we know that absolute of x is strictly less than a if and only if x lies between negative a and a, or you can say that a is strictly less than a and the greater than negative a. We will use this property because our question is in this form. So this implies absolute of x is strictly less than 2 if and only if x is strictly less than 2 and strictly greater than negative 2. So the solution interval for above inequality will be negative 2 and 2. This interval will be, because here we have strictly less than sign, so we will use these round brackets, open interval we will use. And how we can write on the number line, as we have here the origin. Let's say here we have negative 2 and here we have 2, so this would be the solution interval. But here we will use this, we will draw this hole because this is not this, we will not fill up this circle because this is 2 and the negative 2 is not included in this interval as this is open interval. So this will be a solution interval for this inequality. And for example, there is a question, another question 20. There is another question number 20, that is absolute of x is less than equal to 2. Now here we will use another property, that is absolute of x is less than equal to 2 if and only if x is less than equal to 2 or greater than equal to negative 2. Actually here we can use the property. Which property? So I forgot to mention here. Actually we are using this absolute of x less than equal to a if and only if x is strictly less than less than equal to a and greater than equal to negative a. Actually we are using this property now here in this problem, because here we have this symbol and we will use this one while solving this kind of inequality. So this imply we have the interval, solution interval will be, now this time we will use the closed interval. This would be, and how we can draw it on the number line. Let's say here we have negative 2 and here we have positive 2. So this would be a solution interval. Now this time we will fill up this circle because the starting and ending point are also included in this interval. This is a closed interval. So while we will solve this kind of inequality, we will use this property, and whenever we have strictly less than, like here we have strictly less than 2, so there we will use this property. And there we will have this open interval, the solution, and in this way we can represent it on the number line. And for this inequality we will have this solution interval. This is a closed interval and we can represent it on the number line in this way.